we have 2x plus 3 plus 2y minus 2 into y prime is equal to 0. This is a differential equation. So this part is simply equal. We can say that it's what? It's m x y. Then this part is simply equals to n x y. All right. If we must take partial derivative of m divided by partial derivative of y must be equals to partial derivative of n with respective to x. Then if this takes place, if they are equal, we're supposed to have to check, then we'll have our exact. So let us try and check that if this will take place there. Partial derivative of m with respective to y is equals to what? We have 2x plus 3 here. This will simply equals to what? 2x is simply equals to 0 plus 3 is 0. This will simply equals to what? To 0. What about partial derivative of n with respective to x? This is what we have there. We have 2y minus 2. Alright, still this will give us 0. Okay, so we have 0. So this is simply what? Exact. Alright, we have checked that. That will be our exact. Since that is taking place, we have checked that is exact. So we must know that u must be equals to integral of m respective to what? Dx plus some function of y. Whereby we know that u is the same as 0, also u is the same as c. So we know that if we take the partial derivative of u with respect to y must be equals to n. You will use these conditions. Alright, we have those conditions there. So I'm having u is equals to the integral of m. There will take it here. Here it is. This guy will be 2x plus 3 plus some function of y. Then integral of these two, that will be x squared. Obviously we have to divide by that. We'll cancel that 2 plus this will be integral of 3 will be 3x. We'll have that to be 3x plus some function of y there. Alright, we have this now. So we said we'll take the partial derivative of this. Now we'll take the partial let us take the partial derivative of u with respective to y. Alright, then this will be 0. We'll have that will be what is 0. Then this will also be plus 0. This will be plus k prime of what? Of y, like this. So, but we said the partial derivative of u with respective to y, we said is equals to n. We have established that. So since that is equals to n, we can boldly say that this will be equals to what? This is equals to what? To n. Alright, is equals to what? To n. So we have k prime of y equals to our n. What is n? N is 2x minus 2, like that from there. So here we'll take derivative with respective to y, both sides. We have that in respect with respective to y. All right, then the inside derivative of k prime of function of y, this will be k function of y. This will be equals, we take the derivative of 2y, will simply just cancel, will be y squared. There, when we divide by 2, we'll cancel that 2. We have again, this will be minus, we have 2 there. We multiply this by y, since that it's a constant. All right, we'll multiply that by y. Right, this is what we have there. We multiply that by y. This is what will take place. But we also have here our some constant c there. So we have this now. We can substitute this back there. So we'll substitute that back. So we substitute that back. Substituting this, we have our u there. We have x squared plus 3x. Then this guy is equals to this, will be plus y squared minus 2y. Alright, we have said u is equals to c. So c will be equals to x squared plus 3y plus y squared minus 2y. So this is what we have there.